Hi everyone, so I wanted to go over temperature measurements with you. And you know that there are Fahrenheit measures and Celsius measures. In science, we use Celsius measures, and you'll be using that as well. The two different measures differ in their 0 points, and Fahrenheit has a 0 point at the freezing point for a mixture of water and ice and salt. And it's a long and interesting story that we'll get into in a second. But the difference is that Celsius has a 0 point at the freezing point of water alone. And to get into the history a bit, if you're interested in it, Fahrenheit goes back to 1724, and Fahrenheit, the man who devised this system of measurement, his goal was a system of measurement that went from the lowest temperature noted in Europe to the highest temperature noted in Europe over a span of 100 degrees. And he wanted to be sure that he included a human's normal temperature. And in doing so, he said that the lowest possible temperature could be what he sees as a possibility of water and ice and salt like he would see at the ocean. And that froze at 0 degrees Fahrenheit. And about the hottest day that he ever saw in Europe, he noticed on his mercury scale at about 100. And then he divided up everything in between by twos and developed the Fahrenheit scale. The Celsius scale was developed in 1742 by a Swedish researcher whose goal was to separate the phases of water between freezing and boiling. Very different goal. And then he set up 0 to 100 between freezing and boiling. Now, obviously, for science, which deals, especially with biology, which deals with all the phases of water, because without water, life is not possible as we know it, Celsius is going to be what we are using because it's a 0 to 100 scale over the phases of water that are so consequential to life. So that's why we use Celsius. I've already told you the long story about freezing points. When it comes to boiling points, it gets even a little bit more interesting. The Fahrenheit scale, the goal was never to talk about the boiling point of water. And later, in the 1700s, it was determined that the boiling point of water was a lot higher than the highest temperature that they noted in Europe. In fact, the boiling point of water going up by 2 by 2 by 2 was 212 degrees. And that was an afterthought to work the Fahrenheit scale up to the boiling point, because that wasn't the goal of the Fahrenheit scale. And with the Celsius scale, of course, the goal was to go from the freezing point of water to the boiling point of water. When Celsius, the man, made and created the Celsius scale, it was very interesting because he put the boiling point of water at 0 degrees because he said the boiling point of water is very susceptible to pressure. And it is. The boiling point is different at sea level than it is at 1,000 meters up or 2,000 meters up or 3,000 meters up. So Celsius standardized everything in his measure at 0 degrees for the boiling point at sea level. Well, that seemed a little crazy to put the boiling point of a hot point at a lower value than the freezing point, which Celsius put at 100 degrees. So that was very quickly flipped. And the inverse of Celsius's original measurement is now used. 0 degrees is the freezing point of water. 100 degrees is the boiling point of water in degrees Celsius. It's kind of interesting about the pressure. you should know that in reading the temperature, we are reading the level of mercury that is activated by the energy in the heat. Okay, so the energy in the heat expands the mercury and we read the level. Reading the level is very interesting on mercury because we normally think of a meniscus as a shape of a fluid. So the shape of the fluid has to do with the cohesiveness of the bonds between the fluid. When we're looking at mercury, mercury is a metal, a liquid metal, and it is so well bonded that it has a meniscus that has a shape to it that is convex and that actually has more bonding to the mercury than to the glass, so that the mercury is going to have a convex or a top level that you read the center level of the meniscus for mercury and you read the top of the meniscus. And if you go to CCM, there is a great thermometer in the lab that I work in, and you can see the meniscus of the mercury and you read it at the top. We'll talk about the meniscus of other fluids when we talk about volume. When you read a thermometer accurately, you also want to make sure that you keep your hand away from the bulb, because the bulb is metal and the metal bulb conducts energy through to the mercury. If you put your hand there, you are going to be converting your energy from your body warmth onto the thermometer. So you always hold it at the top, and you always make sure that you read it at eye level. Don't read it low, don't read it up, because you are working on a system that actually is called parallax, and I teach astronomy as well. So those angles become very important in astronomy. They're a little bit less important in biological purposes, but please get into a good technique of reading a thermometer right at eye level so that you're getting the angle of the meniscus at just the right level. Now you're going to be working on a lab that asks you to read thermometers well and report them accurately. So you're going to be seeing this thermometer challenge. And what you need to know for that is you need to know how to very accurately read a thermometer. And that might seem like no problem at all, but let's talk about it. So when you read a thermometer, you start low and you move high. And you start with the measurements that are covered by the mercury. For instance, we look at the big measurements first. There's 50. It's covered by the mercury. 60 is not covered by the red mercury. So we take what's covered, 50, and we'll put it in here. And you will press the 5 and put that in. And then it'll move you to the next digit to the right. And you look for that next digit. You see 50 here and you see 60 here and lots of tick marks. You figure out what these tick marks represent. Sometimes they represent 1 degree, sometimes they represent 2 degrees, sometimes they represent 1/10 of a degree or 0.2 degrees. You got to figure that out for yourself. In this case, we've got 50 and we've got a bigger tick here in the middle, probably 55, right? 56, 57, 58. We've covered up to 58, but we're not quite to 59. So we're covered up to 58. We take that, we put that 8 in the ones position. The last measurement that you take always in science, is an estimate. And that last measurement here is an estimate of the tenths. And in this case, we've got 58 down here. We probably got 58.5 in here, but we're above 58.5. But I don't think we're at 58.9. I would say we're at 58.8. It's an estimate. You put the 0.8 here, you check your answer, and you see how you do. I hope that helps you to get ready for your lab. And I will see you on the next video.